Okay, we are going to continue 5.3 today, but we're going to solve some equations that will require us to use inverse functions, meaning we can't get an exact answer from the unit circle, so we'll have to use the inverse function. Okay, so for example 10, let's see, tangent squared x minus 3 tangent x minus 4 equals 0. It already equals 0, it's quadratic. I'm going to go ahead and factor it. Minus 4 plus 1. And then if I use the zero product property, I get the tangent of x is equal to 4, and the tangent of x is equal to -1. Okay, now I'm going to have to think about this a little bit. Okay, I like to look at the unit circle. You might like to do it in a different manner. Okay, now the tangent of x equals 4. There's nothing wrong with it equaling to 4. The problem is I just don't know an exact answer for it. Okay, because I don't know an exact answer for it, I have to use the inverse tangent or the arctangent to find an answer for it. Okay, so if the tangent of x is equal to 4, then x is equal to the arctangent of 4. Okay, but because there is no limit on the domain, I have to consider all the coterminal angles to this. Because the period of tangent is pi, I'm going to add pi n, and that should give me all the other points on this circle that give me an equivalent answer. I don't know where arctangent is for, but if I imagine it's here somewhere, if I add pi, I get the one in the other quadrant. Okay, and I'll include I will get all the coterminal answers that way. Okay, now for my second answer, I also have that the tangent of x is equal to -1. That is a location I can find on the circle. Okay, so the tangent of x is equal to -1 is over here. It's also over here, but because of the period of tangent, I only have to list one of them, and then I can catch all the other angles using the period of pi. So let's use 3 pi over 4 plus pi n will capture all the other angles, this one, and all the coterminal ones to that. Okay, and these are the exact answers for that equation. Okay, for example 11, it's similar, but we're gonna consider sine, which makes it a little trickier. This also has a limit on the domain, so I'm only gonna go from 0 to 2 pi. Okay, now the sine of x equals 2/3. It's between -1 and 1, which means it is a valid equation. So there is a solution to it. I just don't know what the solution is. But I should know that one of the solutions is going to be the arc sine of 2/3 or the inverse sine of 2/3. Okay, but that's not all the answers because we normally have 2 answers every time most of the time when we're looking at the unit circle. So let me think about this. Okay, so let's see. X is the arc sine of 2/3, which is positive. So let's just say that x is here. Okay, this is the arc sine of 2/3. Okay, where is another location on the unit circle that has the same sine value? Well, the same sine value would be the same y value. So if that's x, then if I go over to this quadrant at the same y level, here's another answer to that equation. I just don't know what that is, but I want to find a representation for that. Okay, so but if I know if that distance is x and I know that this is pi over here, this location can be represented by pi minus x, because if I start at pi and I go back x, I will get to that location. So my second answer for 0 to 2 pi is pi minus, what was my x? Arc sine of 2/3. And that gives me 2 answers between 0 and 2 pi that satisfy the equation. Now, if you're doing a WebAssign or something that asks you to do an approximation, you could do arc sine of 2/3 in your calculator. It's sine to the -1. Make sure you're in radians. If you put in your calculator, you get about 0.7297. And then for my second answer, I would do pi minus arc sine of 2/3. It will give me about 2.4119. Okay, I don't like decimals, but the nice thing about the decimals is I can see clearly these are both between 0 and 2 pi, because 2 pi is about 6.28. And I could also confirm my answer. If I did the sine of 0.7297, I should get about 2/3. And if I did the sine of 2.4119, I should get about 2/3. So that is a nice way to confirm your answer for things. Okay, now let's look at example 12. Example 12 is sine squared x plus 2 sine x minus 1 equals 0. Okay, my first thought is to factor this. But if I think of the factors of -1, 1, and -1, they're never going to add up to 2, which leaves me the option of either completing the square or quadratic formula. I'm going to go ahead and quadratic formula this. Okay, normally it's x equals -b plus or minus blah, blah, blah. Because this is sine squared x, I'm going to say sine of x is equal to -b plus or minus the etc. Okay, -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I'm going to go ahead and simplify that, and then I'll see what I'm left with. What is that? 4 plus 4 is 8. If I simplify the square root of 8, 4 times 2, so 2 root 2 over 2. So after all that, I get sine x is equal to -1 plus or minus root 2. I could have also completed the square because that's a pretty nice answer for completing this square. Okay, now I need to figure out how to write my answers. There's no domain restriction, but this requires some thinking, and I have 2 possible answers. So let's consider each answer separately. Okay, so one possibility is that the sine of x is equal to -1 plus the square root of 2. The other possibility is that the sine of x is equal to -1 minus the square root of 2. Okay, I have no idea what this is going to be, but let's see. -1 plus square root 2, is that between -1 and 1? Yes, that's going to be between -1 and 1, so at least it's a valid answer. So if I do arc sine of -1 plus root 2, I should get an answer for this equation. Because there's no limit on my domain, I have to add 2 pi n to include all coterminal answers to this particular answer. Okay, now the fact is the unit circle normally has 2 locations with a sign value. Now how do I get the second answer? Okay, just like on the previous problem, I don't know which quadrant my answer is in, but if I assume that x is here, it might not be here. The other location with the same y value is over here. And how did I get there? I did pi minus x, and that pattern holds no matter which quadrant I am in. It's just convenient for me to think about quadrant 1. So my second answer for that first equation is going to be pi minus my x value. And then because I could have coterminal angles to that, I say plus 2 pi n. Okay, now let me consider the second possibility from the quadratic formula. It's also possible that sine of x is equal to -1 minus root 2. Okay, first let me check my domain. If I do -1 minus root 2, that's -1 minus 1 point something, that's -2 point something. That actually doesn't work because the range of sine is between -1 and 1. So thankfully that equation has no solution, but I still have these solutions over here that gives me infinite valid solutions. Okay, we're going to do 2 more examples, and we're considering the answers for cosine when we're using inverse cosine and how to find the alternate answer. Okay, first let me isolate the cosine. So I'll move the 3 to the other side and divide by 5. So I get the cosine of x equals 3/5, which is okay because that's between -1 and 1 for the output of cosine. Okay, so one of the answers will be arc cosine of 3/5. And because the domain is all real numbers, I will add 2 pi n to include all coterminal answers to that location, even though I have no idea what that location is. Okay, now I'm going to consider the unit circle so I can think about where would the other answer to this be. Okay, let's say I assume x is in quadrant 1 because it's easier for me to make a general rule for it. Okay, if this is x and it's arc cosine 3/5. Where's the other location with this same cosine value? Okay, that's going to be down here. Okay, there's different ways to give that location a name. One way would just be to call it negative x. The other way would be to call it 2 pi minus x. Both ways are correct. Whichever way you prefer is fine with me. They're equivalent in your calculator. That will give you similar or equivalent answers. Okay, so if arc cosine of 3/5 plus 2 pi n is one of my possible answers, then the negative arc cosine of 3/5 will give me the other location in the unit circle that has the same cosine value, and I will add 2 pi n to include all coterminal angles to that value. Okay, and again, if you would rather write 2 pi minus arc cosine 3/5 plus 2 pi n, that would be an equivalent value, equivalent answer, and would also be correct. Okay, one last example. Okay, secant squared x plus 2 secant x minus 15 equals 0, but I'm restricting from 0 to 2 pi, which normally makes it easier, but in the case of inverse functions, I believe makes it a little trickier. It does equal to 0, so I can go ahead and factor it though. Let's do minus 3 plus 5. So secant of x is 3, and the secant of x is negative 5. I'm going to flip this over so I can consider cosine. Okay, now cosine x is 1/3. That's between -1 and 1. That's a legit value. Okay, so one of my answers is going to be the arc cosine of 1/3. Okay, and that's going to give me a positive value, which is great because I'm restricting myself from between 0 and 2 pi. So no plus 2 pi n, because I only want the actual exact answers that work. Okay, now the other answer that works. Okay, remember, this is one of the answers. The other answer is down here. Okay, I would normally call that negative arc cosine 1/3, but that's going to give me a negative value, and that's not between 0 and 2 pi. Okay, so I have two ways to write it. Okay, I could say I thought it was going to be the negative arc cosine of 1/3, but that's going to give me a negative answer. So I want the coterminal angle to that is positive, so I'm going to add 2 pi to that. Okay, that would give me a positive value, and it would be between 0 and 2 pi. You could also say 2 pi minus arc cosine of 1/3, and that would give me an answer. Okay, so those are my two answers for that factor. Okay, now the cosine of x equals -1/5. Okay, the range is okay, so I'm at least okay with that part. Okay, let me think about my answers. I want to say it's arc cosine of -1/5. Okay, it seems right, but let me think about it before I confirm, because it has to be between 0 and 2 pi, and I need to be careful. Okay, arc cosine is between 0 and pi, so -1/5 means it's somewhere over here. This is my x. It's in quadrant 2. That's between 0 and 2 pi. That's an okay answer. I'm okay with that. Okay, now for my second answer with the same cosine value, that's going to be down here somewhere. Okay, so I might call it -x. I might call it 2 pi minus x, but I need to make sure my answer is between 0 and 2 pi. Okay, so if I want to call it negative arc cosine of -1/5, that's an okay value, but it's not between 0 and 2 pi. So in order to make it between 0 and 2 pi, I'm going to add 2 pi, so it becomes a positive coterminal angle with the same value. Okay, there were 4 exact answers to this, and these are the 4 answers that work for this equation.